Earth's surface is covered with 78% of ocean, and the ocean produces over half of the oxygen in the world and absorbs 50 times more carbon dioxide than the atmosphere. You might have seen many Hollywood movies such as Deep Impact and In the Heart of Sea, in which they suggested that an ocean impact would produce a devastating tsunami that would affect everything along the seashores. Keeping in mind this point, let's assume for a while that what would happen if an asteroid from outer space hits the ocean surface. You're watching Gateway to Knowledge, and today I will highlight the consequence of asteroid impact on the ocean surface. Generally speaking, getting hit by an asteroid is a bad day for life on Earth. Wandering in the universe, the space rocks fly around the interplanetary space with no regard for Earth's precious biosphere. If they have our planet in their sights, they are going to hit us, and depending on their mass and speed, they could hit us hard. But depending on where an asteroid hits, the fallout will vary greatly. If an asteroid was predicted to hit land near a major city, we might be able to evacuate in time, but the damage to society, infrastructure, and economy would be terrible. But if an asteroid hits one of our oceans, the scope of the impact is yet poorly understood. To better understand the realities of this massive impact, a team of geologists and astrologists have made a 3D model of ocean impacting asteroid. Never before has an impact scenario like this been studied in detail, and the simulation revealed that the devastating post-tsunami impact that we see in movies are as fictional as the 3D model presented here. Moreover, to create a tsunami, you need something that disturbs the entire water column. For example, throwing a rock into a pond, the energy of the rock hitting the water will produce waves, but the ripples are very dispersive. In other words, they lose their energy very quickly. These dispersive waves in an ocean will be very localized and won't have the energy that a tsunami does. Tsunamis occur when there is a large-scale shift of mass in the seabed, such as during a submarine earthquake or landslide. These shifts causes a huge movement in the massive column of water from the seabed to the surface that can create wavelengths of 100 kilometers or more. Tsunamis are not very dispersive, and therefore they don't lose their energy as they travel through the ocean basin, so hitting the coastlines hundreds of kilometers away from them and producing devastating results. But that's not to say an asteroid impact in the middle of an ocean wouldn't be dramatic. It is going to be spectacular. They would produce splashes that goes up to 10 kilometers in height. That's awfully high, but unless it is very close to a shore, it is not going to be very dangerous. In addition, a significant fraction of the kinetic energy of the impacting asteroid will go into vaporizing huge quantities of water. Water vapor is a potent greenhouse gas, so the injection of water vapors in the stratosphere could linger for months or years, altering global climates. To understand further how an asteroid impact would affect the Earth, let's consider that an asteroid of size 300 meters wide hits the Earth. We can use this ocean impact as a strategy to limit global damage. I think it gives us more options. If you find an asteroid in this size range and it is going to collide with the Earth and you can't deflect it from hitting the Earth's surface, you might be able to deflect it into the middle of the ocean. Although NASA and other agencies are working to identify and track asteroids that pose a significant threat to the Earth, we could be blindsided and have little time to prepare a mission to knock the asteroid, of course. But now we have more of an understanding about how an ocean impact may go down. We might be able to slightly nudge it towards a new target that will produce less collateral damage, like the middle of the ocean. Hope you enjoyed my today's video. If you did, then hit the like and subscribe to my channel. But don't forget to give me your suggestions in the comment sections below.